Welcome back guys. Today we are going to solve LeetCode problem 94 binary tree in order traversal. Before we start looking details about the how we are going to solve this problem, I just want to mention that I often create videos regarding LeetCode problems solutions using Java as well as Java G2E interview helpful material videos. So please subscribe to this channel. Your subscription will be helpful to keep the channel. So let's look into this problem in more details. So given the root of binary tree, return in order traversal of its node values. So they have given this example. So as you can see, the in order traversal will be 1, 3 and 2, right? So let's take a bigger example over here and I can explain in more details how in order traversal work in binary tree. So we can implement the solution. So we are going to first how the in order traversal work is we traverse all the way to the left of the tree, like we go to the 4 and then we go from here like 4 then 10 then 12. So we go like this, 12 then 15 as you can see here. So 4 then 10 then 12 then 15. So we reached here, then again we go to the left, so we go maximum to the left, so we are here at 18 then 22 then 24. So first always visit like left node, then middle node, then right node, right? So as you can see here, so 15, 18, 22 and 24. So we reached so far here. So from here we will again backtrack all the way here. So we will print the root here. So this root is here, right? 25. Again we will have to go to the leftmost side of the right tree, this right subtree, right? So we will go to the leftmost side. So we reached here 31. So we will print 31. Then again we will go from in the middle, which is 35, 44. So we will print here 35, 44. Then we will go to the root here, the subroot 50, then 66. So 50, then 66, and then we will visit 70 and 90, right? So like this, so 70 and 90. So this is in order traversal. So this is the example I took, it is a binary search tree. So you can see that the in order traversal of a binary search tree will give us the sorted numbers, right? As you can see, these are the sorted numbers. So we will get sorted order actually when we are doing in order traversal of a binary search tree. But this is a generic question for that is asked for just any binary tree. We have to just print the in order traversal. So we are going to implement this solution in a recursive way, where we will go all the way down here first, and then we will start printing the left node, then the middle like the root node, then right side, right? So let's look quickly at the implementation. So we have to return a list of integers, right? So I just created a list of integer, it's array list, and we implemented this in order function, right? And it is a recursive function we are going to call. It's just nothing, it's not returning anything, so it's void, and we are passing the root and the list that we created here, right? So this is what we are passing. So first thing is the base condition that we will be checking in the recursive function. So if root is null, means the node that we are receiving here is null, then we are going to return, right? So for example, if you are at a 4 and you are passing the left, this is null, right? So this is null basically. So left is null and right is also null. So in this case we will just returning from here this function. Otherwise we will just call this in order function recursively. So we will do it on the root dot left and then result, because first we want to print the left side, right, of the tree. So we will call the function first and then on the left side, and then we will be adding the result, right? The roots value into the result, and then we will call the right side, basically the in order root dot right, and we will pass the result. So in that way it will automatically it will print the in order traversal, right? So this is how the recursive function works in order traversal. So we first call it for left, then we are adding the value into the list, like then first 4 will be added into the list, then 10 will be added, then 12 will be added. So like that it will be working. And then in order we will call for right side of the tree, root dot right and result, right? So basically you will start from 25, then you will do this for whole subtree. This is the whole subtree of 25, for example. And then once you are done with this, then you add basically this 25 into the list, and then again you do that recursive function for whole right side subtree, right? So that's why this 25 will be in the middle, and then it will again go like the call will go recursively, right? And then for example it will then first it will reach this subtree because it is going recursively. Then in this case we will first add that 4 into the list, then it will add 10 into the list, and then it will add 12 into the list, because it is kind of, we are calling it recursively here. So the implementation is very simple and straightforward, just one recursive call, and then it gives us the list of numbers, the in order traversal. So we'll just take the test case they have given us here, and we'll just make sure this is working fine, and then we are getting correct result, so we'll submit this code. So as you can see, we are getting 100% 0 ms. So this is a way you can implement the in order traversal. So if it is like a instead of in order, if they ask us like a pre-order, right? Pre-order. So pre-order means first we have to put in, pre-order means we have to first put that value into the list basically, and then we will do left, and then we will do right basically. That is a pre-order. So let me just go back from here a little bit, and I can show you quickly. So in order we already saw. So pre-order, let's say we just have this simple small tree, right? So pre-order means we will first put 10 here in the pre-order, then 4, then 12.